Good morning. Good morning, all. Namaskaram. Uh, it's been a long dream for us at Kalasuruchi to start something on history of science. For almost now 2-3 years, I would guess. But as they say, this is an idea whose time has probably come now. And I really thank Kutuhali to kind of collaborate with us to make this happen. You probably know that we are conducting Mysore Science Theatre Festival for about 5 years now, right? And most of the theatre is rooted absolutely on history and then history, politics, etc., etc. So while we study on everyone's personal thing, there was always I think, a need for a presentation followed by a dialogue, right, amongst us, amongst the right-thinking individuals in Mysore and of course, elsewhere as well. Now, incidentally, Mysore University has a history of science, used to have a history of science department. Right? And if you go inside the beautiful University of Mysore, near the gate, you will take a left. You will see a building, even today, which has a board called History of Science. But if you go inside the board and ask, there is no department. Only people who are non-academic. It is used as a seating place for non-academic, non-teaching staff there, and it's a kind of sign of times, right? Sign of times that in a university where such a thing ought to happen is not happening. And anyway, I don't think right-minded people wait for government or anybody else to start. And I think it's right, Ernest, that we start this activity. We have in this series, this is likely to be, or this is going to be a quarterly program. So every 3 months, we will get together like this in the morning, spend about 1.5 hours talking, discussing subjects on history of science. We have no right and left of history here, right? And I'm sure all of us go through the waves of history within the country. We start with left and then go to the center and then probably go to the right a bit, and we are probably in the right of that center right now. But in our case here, so we will not lean towards any of the isms here, and then we will look at it history as much as possible with a non-partisan kind of a view. And we also don't have any particular view of history of science, right? There are multiple genres, multiple colors you could have. It could be on a particular topic, right? For example, history of light could be the entire thing, so you can take from wherever to wherever. It could also be on a particular individual, right? I mean, how Einstein or anybody else got this through, and then what are the tribulations he faced, etc. It could be individual, it could be political. I know during, for example, between 1935 and 1960 or even 70, atomic bomb used to be the national agenda for every other country. Every other country. That could be a theme, right, for history of science, how it shaped public opinion and then things like that. So I am honored, right, to invite Siddhartha Kankaria here, who is going to be our first speaker in this event. He is a science communication practitioner and has a background in biology from Indian Institute of Science, and he is the science communication program coordinator at National NCBS Bangalore, right, the National Center for Biological Sciences. So obviously he is in the center of first grade science, world class science being done in our midst, in about 140 kilometers away, and I'm sure he is privy, right, to all the all the things which happen within a scientific community. But today he is going to speak on knowledge sharing practices. Science communication is obviously is the new term for us for the last whatever number of years, and I'm sure he's going to speak more. But knowledge sharing has been there amongst us, and then it is interesting that we starting the series with this topic, that knowledge sharing, how it happened across the globe and how it is happening and how it is likely to happen perhaps in the future. Right? With this few words, I gladly welcome. It's an honor to welcome Siddhartha Kankaria, and it's between us and him now. We will follow, now it is 10:45, right? We'll follow about 45 to 50 minutes of lecture from you, and maybe about 20 minutes of Q&A, right? We'll follow that approach, right? So that we can end in time as well, right? Thank you so much.
Thank you so much, Shiji, for a very, very kind introduction. And I'm very, very honored to be here. And I just learned that I'm the first speaker for the talk. So it's an extreme honor. And I am not, I'm a very small person and I do a very small thing. But I'm very, very happy to be here. And so, unfortunately, I'm not a Kannada speaker, so I'll be talking in English. But I will encourage all of you to sort of interrupt me, stop me, ask any questions. I know there is a Q&A in the end, but it's absolutely fine if you want to talk to me, if you want to ask questions. And that's completely going to be fine. So, as Shashiji introduced, it's very, very important to talk about the history of science and understand how science has been happening and how it has been occurring. It's important to also understand in what social-cultural context and in what kind of a context science is emerging, because that really, really shapes science, right? So we think that science is objective, science is, sort of supposed to be happening inside a lab, and science is apolitical. But science is not apolitical. It happens in the sort of the real world with real world people like us doing science, and we have our own backgrounds and ideologies and everything, which really, really shapes science. And I think it's important to also understand that science is not supposed to be neutral. Science can become positive or negative depending on how we use it. And it's our responsibility to understand how to use science in that. Okay. So I have a very tough job in front of me. I'm going to try to cover knowledge sharing practices, or what I like to call science communication. And we'll get to the term in a little bit. So before I begin, a little bit of a heads up. So part of this, the stuff that I'm going to be presenting today was actually developed as part of the Life Origin University SciComm program. And it was written by me. All the illustrations that you're going to be seeing is by my very talented friend, Orgo Manna. And this course was reviewed by two other friends of mine, Marina Schubert and Bruce Levenstein in South Africa and US. So just to give a heads up to them, because they've really, really contributed to this course, what I'm going to be presenting. So I wanted to give them some credit. All right. So before I begin, let's do a little bit of a mind map. Okay. So I want to ask all of you, what are some of the things that come to mind when you hear the word science? Okay. Anybody can speak. Just raise your hand and tell me. I don't want this to be a lecture. I want everyone to talk to us, talk to me. Okay. So what comes to mind when you hear the word science? What's the first thing that comes to mind? Knowledge. Okay.
Knowing about the facts.
Knowing about facts. Experiments. Discovery. Okay. Reasoning.
Inventions.
Sorry.
Inventions.
Invention, discovery, knowledge. Okay. Curiosity. Yes, I was waiting for that one. What else? Truth. Okay. Very, very strongly loaded word, but very, very important also. Practical. Okay.
Spirit of inquiry.
Spirit of inquiry, scientific temper. Yes, very good. What else?
For betterment of livelihood.
Betterment of livelihood, betterment of society. Yes, absolutely. All right, great. So that was the first question. The next question is, what are some of the things that come to mind when you hear the word scientist? Same exercise. Go again.
Truth seeker.
Truth seeker.
Dedicated.
Okay. Practitioner. Okay.
Nerd.
Nerd. Okay. You can say negative things also. I mean, all the things so far are very positive, but I also want to hear what are some of the negative connotations or negative association with the word scientist. So, anyone wants to share?
Scientists will have long hairs or no hairs.
No long hair or no hair. Okay.
Logical thinker.
Sorry.
Logical thinker.
Logical thinker. Okay.
Socially removed.
Socially removed. Okay. Absent from society, lost in their own world. Nerd. Yes. Does someone think that scientists are inaccessible, or scientists are not easy to talk to, or scientists are in their own world? Yeah, so that's what I was actually trying to get at, and that's very very important because when you talk about the word science, all the words that you mentioned were positive: curiosity, knowledge, truth, finding about the world, and bettering society, bettering lives, and all of that. But as soon as you come to scientist, who is sort of the person who's supposed to be doing science, the connotations are somewhat mixed, right? There are some positive connotations about truth seeker and someone trying to find the truth and finding about the world around us, but there are also some negative connotations that they're lost in their own worlds, they're nerds, they are not very accessible, and I think that is the fundamental reason why it's important to be sharing knowledge or communicating science, right? So I call myself a science communication practitioner, and I say that because I am very, very interested in connecting science with society. And when I say connecting science with society, it's not just telling what science is happening to society. It's not one directional. It's also learning from society what science should be doing. What are the questions that science should be thinking about? What are the things that science should be careful about when we are trying to do science, right? So it's about a two-way dialogue, conversation, back and forth that happens between science and society, and that is at the crux of science communication. Okay. So before I move on, I want to talk about one more concept, which is diversity of knowledge, right? Now we all talked about science and scientists, and we consider scientific knowledge to be sort of the ultimate form of knowledge, or scientific knowledge to be the truth, or sort of objective knowledge that we can rely on, right? But there are many forms of knowledge, right? So knowledge and expertise. So scientist is an expert in something. So knowledge and expertise can be of various different kinds. The first kind is scientific or academic knowledge that we're all aware of, and that is perhaps the subject matter of all the talks in Science Sanje. Also, that scientists who are experts in their own fields of knowledge come and talk to you about their respective, fields of knowledge. But that's one form. Another form of knowledge could be a technical knowledge that you learn by doing something, right? So you could be an engineer or a doctor or someone who repairs something, you could be a mechanic. And that form of knowledge is not as grand or ultimate as the scientific knowledge, but that form of knowledge is also very important because that person is an expert in repairing a car or treating you medically or making a gadget or a device. So doctors, engineers, mechanics are also knowledgeable, but they have a technical form of knowledge. The third form of knowledge is experiential or local knowledge. And this knowledge is many, many times undermined, it is underestimated because a farmer growing a crop in the field has a lot of knowledge about what to grow, when to water, what fertilizer to put. And that kind of knowledge is often underutilized or underrepresented in when we talk about knowledge, right? So scientific knowledge is here, farmer's knowledge is there, but that's not fair, right? So farmer's knowledge, a farmer is an expert in growing crops and feeding the country. And that form of knowledge should also be respected, right? So there is experiential or local knowledge. So farmers, indigenous tribes, patients. So if you have a medical condition, say you have diabetes, and you have a knowledge of living with the condition and what happens to your body on a day-to-day basis, that a doctor or a scientist will not. A scientist might be expert in the biology of diabetes. A doctor will be an expert in treating diabetes. But your knowledge as a patient is equally important. I'm not saying it's all equivalent. Of course, the doctor and the scientist knows more technical stuff about diabetes, but you as a patient also has an experience of living with that condition, which is important to consider and incorporate when you're having a conversation about diabetes. Because sometimes when you listen to patients carefully, you can also find and diagnose new things that doctors and scientists might miss, right? So it's important to also sort of think about experiential knowledge or local knowledge or lived experience that we call, and it's important to consider them also as important forms of knowledge, right? They're not all equivalent, they're at different levels and they're important. Many things are more important in certain contexts, some things are less important, but it is a form of knowledge that we should not be ignoring and forgetting about completely. The last form of knowledge is emotional knowledge, right? The way we feel about something, the way we have values, our ideologies, our emotions, is also a form of knowledge, right? If I am sitting here and giving you a lecture and not listening to what all of you have to say, you will not feel well. And that feeling is also a form of knowledge. So for us to be talking to people about different kinds of things. So we know a lot of people did not believe in vaccines, a lot of people did not believe in climate change, and we keep telling them, scientists keep telling them that you should take the vaccine, you should not take the vaccine, this is important, that is important. But they don't take into account that they need to understand their feelings and where they're coming from also. Many times they're hesitant to take vaccines because they've had a bad experience in a medical condition or something, right? Or they might have genuine doubts or concerns about why they don't want to take vaccines. So unless and until we are humble enough to listen to them and understand where they are coming from, we will not be able to change their opinion, right? And that is at the crux of doing science communication and knowledge sharing. So me as a communicator of knowledge, my job is not just to communicate knowledge from science to society, it's also to listen to what society is saying and understand what is it that's relevant for them. Why is it important to them? why should they devote 1 hour of their time and come to a talk like this, right? What are they going to get out of it, right? Unless and until I can answer that question and have the humility to say that, okay, I'm going to have a conversation, I'm going to learn as much as from my audience as they're going to learn from me. So that humility is something that scientists often are lacking. And I'm speaking that not as a scientist, but as a practitioner of science communication. But I think it's important to also understand where your science is situated in the larger societal context. And unless and until you understand that, you will not be able to connect the society, you will not be able to communicate and share your knowledge with different kinds of people. And we live in a day and age where we have access to so much information, so much misinformation. There are so many WhatsApp forwards, there are so many sort of things which have been published which can be true or untrue. And we cannot sort of bunk every myth or every misinformation. What we need to be doing is we need to make people, enable people to be able to differentiate between what is right form of knowledge and what is wrong, right? So enabling that critical skill, enabling that rational thinking, enabling being able to be skeptical and looking at any form of knowledge and deciding whether it's actually accurate or not is something that we should be teaching people how to fish rather than giving them a plate of fish, right? That's the metaphor we use, right? You teach someone how to fish and they can feed themselves for the rest of their life, but if you give them a plate of fish, they will only eat for 1 week. So I think that is very important. So with that, I will sort of stop at this and start my journey of. So it's also crucial to recognize how to respect different forms of knowledge. Okay. So coming to my idea of science communication, right? So why should we be sharing science, right? So there are many reasons why we should be sharing science. The first is, of course, enabling, engaging people with concepts, skills, and process of science. Also, history of science, because this talk is about the history of science. So we should be engaging people with science because the pursuit of scientific knowledge or the endeavor of doing science is a human achievement in itself, and it deserves to be shared with everyone. Stories of science are very interesting. They are full of tension and drama because every time there is a failure and then there is a troubleshooting and then someone discovers something or someone invents something. And all stories worth telling. And I think Communicator and Shashi have been part of the Science Theatre Festival where they have been showcasing a lot of scientists in their journeys. And the reason why they make for such interesting stories to be adapted into theatre is because the journey and the process of science is itself full of twists and turns and drama and tension and conflict and climax and anticlimax. Right? So the journey of science itself is very interesting, and that should be one reason for sharing science. We should also be facilitating exchange of knowledge between different groups of people, not just who vary or differ in the level of expertise of a technical knowledge, but also their values and emotions and where they're coming from. Okay? And it's also important to mediate interactions between the culture of science because science happens in a very different kind of a culture when you go inside a scientific institution. It's a very different kind of an environment. People do science in a very different way. And the way we live our lives, the culture of everyday lives can be very remote. But there is a way to connect the culture of science with the culture of everyday life. And that is why science communication or knowledge sharing is important. And it can also provide scientists with fresh perspectives and novel ways of engaging with their science. So oftentimes when scientists engage with different kinds of audiences, they can come up with new research questions, they can come up with new things about new medical devices or new medical needs that might be a need that the audience has, and they might actually incorporate that into their science. So talking to different kinds of people also enables scientists to improve their science and think of new ways of expanding the frontier of human knowledge. Okay, so let's not worry about what is science communication. We don't need to be going into definitions. Okay, so now we're going to go on a journey across the world where we're going to look at the history of knowledge sharing practices and the diversity of traditions and approaches that have been used all over the world for communicating science and sharing knowledge. Okay. Let's begin our journey in Europe, in the UK. So there is a museum exhibit on the history of scientific controversies, which is being attended by 4 students. So you can see the 4 students in the picture there. So we are going to assume that we are one of those 4 students, and we are going in this exhibition of scientific controversies, and we are going to learn about how scientific controversies were a very powerful force in making scientists realize that they should be communicating their science. Okay. Okay. So let's begin our journey. So the first exhibit that you see is about the mad cow disease, right? So in the UK, there was a disease called the mad cow disease, which is spread by prions, which are basically protein molecules that get infected and go into your brain and they cause neurodegenerative disorders. And a lot of people were worried about getting it. But the government and the scientists in the UK, this was in the 1970s, by the way, the government and the scientists,
1980s.
1990s. No, actually it started in the 70s, 80s.
It picked up.
It peaked in the 90s, right? So in the 80s when it started, A lot of people were very skeptical of getting the disease and eating beef and all sorts of things. But the government and the scientists assured them that nothing is going to happen. It cannot be transmitted from cows or cattle to humans. So you can do whatever. You don't need to worry. But that turned out to be wrong. You're right. It was the 1980s. Sorry. So the public officials really messed up, and so the science of understanding the disease, the mad cow disease, was still emerging. It was still being developed, very much like COVID. When COVID came in the first 6 months, nobody knew anything. Everybody was trying to figure things out, and the science was still evolving, right? But the scientists and the government officials in the UK said that not to worry, nothing, everything is okay. You go ahead and do whatever you want. You can eat whatever you want, and it won't happen. And as the science evolved, it turned out that the virus or the prime could be transmitted from cattle to humans very easily, and it started causing a lot of deaths in humans, right? And it became a huge controversy where, because the government and the scientists had told the people that there's nothing to worry, all the people in the 90s, when it peaked, as Gurukul said, they started, distrusting science. They said that scientists are liars. They have not told us the truth. They deceived us. They duped us. They, did fraud with us, and they did not want to believe the scientists. So this led to a massive distrust in science. So even though this was about one particular subject in science, biology, disease transmission, it led to a distrust of science as a general, as a whole, right? So a lot of scientists started facing a lot of problems that people did not believe in science anymore. And there are threads of this that we see even today. There are many times when people don't believe in science. They say that scientists are not sure what they're talking about. They keep changing their directive every 6 months. Every 2 months in COVID, the mask mandate kept changing, whether you should wash your hands, whether you should be 6 feet apart. It kept changing. And the reason for that is that scientists were not lying. It's because that science itself is uncertain, right? Science was also evolving certainly. And as and when we got new information, the scientists also kept updating what was the best practice to do. But if someone does not understand the process of science, if someone does not understand that the process of science also goes back and forth, back and forth, back and forth till it reaches incrementally to a point, and that there is uncertainty built into the process of science, if someone does not understand this, they are very, very likely to start mistrusting or distrusting science. And they will think that scientists don't know what they're talking about, so we should not be listening to them. And there is no consensus within the scientific community. But that's not how science works, right? So when we are communicating science, it's very important to tell people that we know this much. We are telling you that we know this much, and based on this information, this is the best thing to do. But this might change in the future, or there is some things that we do not know, and so we need to also be honest about what we are communicating and how we are communicating that science, because otherwise it will lead to a lot of distrust in science. So this controversy happened. And then this is what happens when you don't trust people enough to talk to them openly and honestly about evolving knowledge or uncertainty in science. Officials threw facts at people without listening or addressing uncertainty. So this was a massive flaw or a failure on the part of the scientists in the UK that they realized later on. So throwing facts at people to change their minds is not a strategy that works. It's a very simplistic approach, and it misses a lot of important aspects of doing science communication in a responsible, honest, and in a trustworthy way. Okay. But that wasn't the only reason that public mistrust of science at that time grew. There was also a lack of transparency. So whatever scientists were doing, whatever papers they were publishing, it was not freely accessible to the public, right? So, and there was a lot of ethical guidelines which were not followed. There was no community participation or consulting the public whether they wanted this or not. So there was a lot of issues that happened, that there was no transparency, they were not ethics were not followed. And this led to an even greater problem that people did not believe in what scientists were doing. And it sort of put a question mark to the legitimacy of scientists and whether scientists are the authorities or the experts in figuring something out. So it led to a huge sort of controversy. But thankfully, these failures and these controversies force scientists to think about how can they engage people better, how can they communicate their science better, and how can they reach out to different kinds of audiences better. So this was a catalyzing event which really forced scientists to start thinking about how can we connect with society better. So they often started to look around the world and look at diverse and innovative approaches to knowledge sharing. Some of them we are already aware of. So, for example, the science theater thing, the science history of science talks that Uday and Shashi do. All of these are great examples of connecting science with society, of communicating science to different kinds of people. Okay, so scientists started thinking about, and the field of science communication, more or less in the formal way that we understand today, was born because of this controversy. And we started thinking about that scientists doing science was not just enough. They also needed to connect it to society. They also needed to engage different kinds of people to learn about their science. So one of the methods that they applied was dialogue. And dialogue is nothing but two-way conversation. It's a back and forth conversation, which is something that even I said in the beginning that I don't want to be talking myself, and I wanted to ask questions. So if there are any questions, please ask. So the two-way communication of science better engages people in the process of science, and it allows scientists to listen to the public's concerns also. So if someone is wearing a mask, or if someone is not washing their hand, or if someone has a problem wearing a mask, if they share that with the scientists can rectify that and give them more information about what they can do. Sometimes it's not always possible to wear a mask. Sometimes people have genuine reasons to not take the vaccine. But if scientists are willing to listen to people's concerns and why they cannot take the vaccine, they might be able to come around or find a way to circumvent that or overcome that problem. But if scientists are just saying that you should be taking vaccines, and if you're not taking vaccines, then you are a pseudoscience person or you don't believe in science, that's not going to help people. It's just going to polarize people more, and it's going to make people even more offended, and it's not going to make them take the vaccine eventually. So the idea here is that you need to listen to people, you need to listen to what problems or questions they have, and then try to sort out those questions. So today, scientists and other experts around the world are encouraged to get out and talk to people as much as they can. This is very, very important for building trust using empathy and conversation. Scientists also invite people to weigh in on research questions, best ways to pursue answers, and plans for developing new technologies. So let me give you an example. This is very, very important because if you are not engaging people when you are doing a big budget technological sort of scientific discovery or invention, if you do not engage the people right from the get-go, it can create a lot of problems. For example, if you're building a dam or if you're building a nuclear power plant, if you're not asking the communities who live in that area, if you're not asking what problems will they face, are they sure about this, do they want any assurances, it's very, very important to engage them also. One more example is stem cell therapies, right? Now, stem cell therapies are sort of at the edge of ethics and science because they involve using human fetuses and embryos, and it is a very, very ethically charged question. But if you are developing a stem cell therapy to cause or cure some kind of disease, scientists should not be doing it by themselves. They should also be talking to doctors, nurses, patients, hospitals, and healthcare professionals because it's important to understand their point of view also when they're trying to develop a therapy for a disease or curing a disease, right? So engaging different kinds of stakeholders, different kinds of people who will be affected by that science and technology in the long run is very, very important. Is everybody with me? Do you guys understand what I'm trying to say? Yes.
Is there a mechanism right now for the public to engage with the science other than what the scientists do?
Yes, I mean, the most basic level mechanism is to go and reach out to scientists. Most scientists may not be good at replying emails, but if you do meet scientists, and I think it's important for us to have forums where people can talk to scientists, you can reach out to scientists, you can talk to them. If organizations or institutions are not willing to share information, you can also file an RTI, a right to information act. But that is a little extreme.
I think the reach out should come from the scientists. That's a vertical communication.
No,
Yes.
I have a different this one here. Sorry, is it?
Yeah. Please.
So the scientists do, like Siddhartha, the scientists who had come here, they do go out, but the number is very few. So if we have a question about a general question about certain things, then where do we ask those questions? Is there a forum, or should we create a forum? That's the next question.
See, I think there is always scope for creating new forums, but there are already existing forums which are not meant for this purpose but can be repurposed for this. So, for example, social media. I know social media is very, very sort of myopic and it only is accessible to some people. But on the social media, when Vijay was the PSA, for example, he was accessible. People were asking him questions that I'm not getting funding, I'm not getting this, I'm not getting that, what about this, what about that? And they used to respond. So Twitter or Facebook or social media could be one forum. Sort of writing to institutions and asking them questions could be one forum. Organizing events like this is definitely a very good because you get to have a face-to-face interaction with scientists. But there is a scarcity of forums where people can do this, and I agree. And another concern that I will add here is that a lot of people are not confident that they can ask scientists questions because they think that scientists are way above our reach and they will not listen to us. And that the reason that happens is because we think that scientists are on a pedestal and we are there and we cannot ask them questions. But the fact is that scientists are just like you and me. We also get up and we also have families and same and so on and so forth. And I think it's important in our schools also for us to see positive representation, to have role models that everybody can do science. For example, a lot of young girls do not think that they can become scientists or they cannot become physicists or mathematicians. It's very important for women scientists to come and talk to these people because they will encourage them to say that, I have become a scientist despite all of these things. So can you. So I think there is also a hesitancy from the public that they cannot ask questions and they need to get over the hesitancy and ask questions without, worrying. And there is no wrong question. There is no bad question. The questions, there are only bad answers. There are no bad questions, right? So your question, if you don't know something, it's not your fault because you're not an expert in that field. It's not your fault that you have not studied and done a PhD, right? Someone who has done a PhD should be able to answer your question. If they cannot answer your question in a satisfactory way, that's a bad answer. But your question is not wrong or bad, or So I think that is also something that I will say that we need to get over, and just email them. I mean, most scientists are all their email IDs are publicly on their websites and they're supposed to answer to questions like this. But there are events like Open Science Days where there are festivals and stuff. Those are also great days because those days the scientific institutions want people to come and ask questions. So you can also, like in IISc, Tata Institute in Bangalore, there is an open day that happens in February or March every year, and about 10,000 people come in a single day. And every building, every lab has an exhibit, has scientists standing behind the counter and talking to people and answering questions and all that stuff. It's not possible to do it every day, but I mean there are some avenues like that. But there should be more focus. I agree with you. Right. Okay. Let's move. So some scientists today are also inviting citizens to actively participate in their research, and this is for citizen science. So if you look at an example, there is something called Season Watch, which is done by NCF, Nature Conservation Foundation, where they ask people to use their mobile apps to say what trees are growing in what season, whether the trees have flowers, whether they have fruits, and this is done all across India. And using this data, they're able to sort of build a scientific paper or a scientific research study where they're comparing how trees are behaving from season to season, whether they have proper leaves, whether they have proper fruits and flowers across India, across seasons, across the years. So it is a very, very, very big study. And scientists cannot go to every city or every village in India and do this, but they're asking people with mobile phones to sort of record and share this, and it becomes a fun activity for school students to do. But it's also feeding back into the scientific study, right? So it's not just science for the sake of doing science with people, it's actually feeding into the scientific study also, right? Another example is a zoo universe, which is basically if you're looking at the stars and you identify something, you can take pictures and submit it. And this basically, scientists with telescopes and astrophysicists use all those images to sort of study the stars from different parts of the world and stuff like this. So there's a lot of scientific citizen science initiatives also, where people are invited to come participate in the scientific study themselves. They become part of the scientific process, and they are not expert scientists, but they also feel like they are scientists because they are part of doing the process of science in small ways. And I think that's a great way of also encouraging people to sort of become involved in the process of science and identifying that they can also become scientists. I think that is the biggest barrier, that people don't think I can do science because it's too hard, it's too technical, it's too difficult for me. Every single scientist also felt that way at some point of the other, right? But they have gone and become a scientist despite doing that. So if you have kids, if you have relatives, if you have young sort of adults in your family, please encourage them that you can become scientists, and there are obviously ways to that they can get exposed to more science. Okay, so that's a short history lesson, and public controversies about science in the last 2 decades have really forced scientists to rethink and revalue how to creatively reach out to different kinds of audiences. But the real history of science communication dates back much further. Now, the academic field of science communication started in the UK when the mad cow disease controversy happened. But actually, knowledge sharing practices have been happening all over the world for thousands and thousands and millions of years, right? As long as humans have existed, we have been communicating knowledge to each other. And when I say knowledge, it's not just science. I want to expand the definition of knowledge to science, social science, humanities, how to farm, how to cook. All of these are forms of knowledge also. The fact that you can make amazing dishes in the kitchen every day, that's also a form of knowledge, right? It's not scientific knowledge, but it's also a form of knowledge which we have been communicating, right? We have been passing on from one generation to another. We have been writing recipe books, we have been writing cookbooks. So all of these are forms of knowledge, and humans have been engaging in knowledge sharing practices for as long as they have existed. Okay? So let's look at a few more examples from across the world, which is not just centered in Europe, but also a little bit more global. So this student basically is saying that I always thought the science communication was a recently started practice. That seems so because most modern accounts of science and science communication is very, very heavily biased by the Renaissance era that happened in Europe, right? We think that science is a Western construct, that it started in Europe, it started in US, it only happens in English, and we cannot do enough science in Kannada or Hindi or Bengali or Telugu or Tamil. But the fact is that every one of us has been thinking in a scientific way. We have been observing things, making deductions, and deciding whether we should do this or not, whether this is the truth or this is not the truth. And that is the definition of scientific thinking, right? As long as you observe the world around you and you decide whether something is true or not true, that is the definition of science, right? So all of us have been engaging in different ways of doing science, even though we are not scientists, quote unquote scientists in the definition of a scientist. But we have been engaging in doing science in our own small ways. Every time something is malfunctioning, in some device is malfunctioning, or something breaks down, when you repair that, you're using scientific principles to repair that, right? So all of us have been doing science all along. So then again, the student asked, did modern science communication and science both originate in Europe? But that's not true. A wide variety of cultures have been engaging in systematic ways of knowing and understanding the world for many millennia now. They have been sharing their knowledge for just as long, exactly what I said. And here are a few examples of different forms of knowledge that are basically ancient civilizations. Like in the Harappa civilization, we had like canals and waterways. And even though it was much before the Renaissance era, we actually had proper drainage systems. You can also see that people were doing astronomy and observing all the stars and celestial bodies. And in India also we had the concept of zero. We had very advanced level of medicine and surgery that was being practiced. So scientific thinking and scientific thought has existed for a very long time, and it's not just something that came out of Europe in the Renaissance era. It's been there all along. Okay. So different kinds of cultures have also been crafting signs, images, words to communicate many of the different types of written and spoken wisdom. Another thing that I want to mention is that a lot of scientific knowledge that we talk about is often written down. And in the West especially, when you write down scientific knowledge, it is seen as a scientific knowledge or a paper or something. In India, a lot of our knowledge sharing practices are oral. We have oral storytelling traditions, we have folk traditions, which are not written down somewhere. They are practiced and orally sort of transmitted from one generation to another. And that is equally an important form of knowledge sharing as any other written output, right? So that's also something that the West does not recognize as a valid form of knowledge output. But I think in India we should be, because we have always had folk traditions and cultural traditions which have been transmitted orally by singing, by dancing, by doing all these theatre and skits. And I think that's very important to recognize that forms of knowledge can also be different. It does not always have to be written. It always does not have to be documented in the way that the West thinks that it should be documented. It can also be in many different forms of knowledge. Okay, so let's move from the UK and go to Australia. The Aboriginal people in Australia, which were the ancient indigenous people in Australia before Europeans colonized Australia, have been using oral storytelling for thousands of years to pass on knowledge about agriculture, tool making, geology, astronomy, and natural disasters. Even today, their oral storytelling traditions, you will hear examples of earthquakes, of floods, of tsunamis that happened 10, 20,000 years ago. And it has been transmitted from generation to generation. And it's very precise information about where to live, where not to live, what to do when a tsunami comes. And all of these things we have forgotten. And we had to learn the hard way when the 2008 tsunami came. But these are all ancient forms of knowledge which have existed and have always been transmitted. And so these indigenous people actually have survived because they knew how to deal with tsunamis and floods and earthquakes and volcanic eruptions. They've also been looking at stars and making deductions about seasons, about all kinds of things. And a very important thing that they have been doing is that their knowledge basically comes from observing nature and people's life experiences. So it's not something that nobody is dedicated as a scientist separately and they go do science separately. Everybody observes nature around them, everybody uses their own life experiences, and then this becomes basically a form of knowledge, but also a form of sharing knowledge. So their knowledge creation and knowledge sharing are intertwined. They're not separate things that, like today we are doing. So scientists do science, and science communicators like me communicate science, right? They are two separate activities done by two separate people, right? But essentially in the Aboriginal tribes, knowledge creation and knowledge sharing were basically one and the same. So creating knowledge was the same as sharing knowledge, because the sharing of knowledge was also a way of creating knowledge, right? So these two things are actually intermeshed, they were intertwined, and they were not as discrete or separate as it appears to be today. Because of this reason, they were much more easier to understand, because all the knowledge was shared using an oral storytelling tradition. A lot of people understood that much better. All the people who needed to understand that science were able to understand because it was in a story format, and we did not have this problem of creating something which is very technical and then trying to find ways to communicate that in a non-technical way. Right? When you are using stories to talk about science, the science becomes accessible and understandable to everybody and everyone. So today's scientists can learn a lot from such practices about harmoniously moving towards holistic knowledge. And what do I mean by holistic knowledge? I mean a mix of scientific knowledge, skill-based knowledge, and lived experiences. The types of knowledge that I outlined in the beginning of my talk are basically if you can combine all of these things. So even when scientists are sharing their knowledge, if they can talk about their own journeys in science, if they can talk about how did they fail in the lab and how did they overcome that failure, it becomes much more interesting for people like us to listen and understand what the science is saying, as opposed to someone just talking about I did this P53 gene mutation in this DNA, blah blah blah, and that just goes above our head, right? It doesn't matter. So I think using stories in science is also very important, and that's what the Aboriginal tribe were really, really good at. Now let's look at one more example. I have, how much time do I have? Another 15 minutes?
Yes.
Yes? Okay. So let's look at one more example, which is the West African storytelling tradition called griots. Okay. Now griots are basically jack of all trades. They are someone who were storytellers, they were poets, they were musicians, they were local historians. Very much like Jatra people, like if you know in Bengal there's a Jatra where there's a theatre troupe which goes from village to village. They perform, they sing, they dance, but they also do social commentary. So these griots were not scientists, but they were actually experts in a lot of local sort of politics and culture and knowledge forms. And they were nomads. They moved from one village to another in Africa, and then they put up songs, dances, theatre performances, and they were sharing a lot of knowledge about what diseases to be careful about, how to clean your house, how to sort of what crops to grow in so and so season, so on and so forth. And because these people were not just sort of people who were just communicating the science, they were also social commentators. So they used a lot of irony and sarcasm and a lot of sort of metaphors to also politically and socially comment on what's happening. So if someone was a corrupt leader in the society, they will not have a separate session for science and a separate session for politics. All of this was made into a khichdi and was communicated in one go. So it was a mix of politics, it was a mix of jokes and humor and stand-up comedy. There was a little bit of song, there was a little bit of storytelling, there's a little bit of dance and theatre. So all of this became like a performance. And because of this, griots were very, very successful at sharing knowledge without making it look like they were communicating technical knowledge, right? They did not give a science talk, but they just had a performance. And in their performance, they managed to communicate a lot of stuff without people realizing that they were talking about all these important scientific information, right? So griots were actually a very great success stories in trying to communicate this without actually making it look like a scientific talk. So griots were repositories of all kinds of knowledge, as I said, history, science, politics, and they often combined all of this to make into a sort of a super kind of a performance. They were entertainers as well as social commentators within the African communities, and because they were so entertaining and so humorous, a lot of communities actually respected them a lot. So they were very welcome in all the villages, and a lot of people listened to them. So if a scientist would have gone and given a talk there, people would not have listened after half an hour. But because they were so entertaining, a lot of people used to listen to them for hours and hours. Right? So from griots, we can learn a lot about combining science with art, music, cultural practices, just like the science theatre festival that Shashi and Kuleveda do. And modern science can learn a lot more from these kind of things also. How can we combine theatre and art and music and dance to make science much more entertaining, much more accessible, much more people's product rather than something that is done in the ivory towers of scientific institutions.
Did they have a written form too?
Sorry.
Did they have a written way of presenting?
No, so griots were only doing live performances, they did not write anything. And that's what I said in the beginning also. A lot of forms of knowledge are not written down, and that is why they're not considered as a very standard or formal source of knowledge.
Do they have a data of what exactly happened in different parts of the world?
So people have written about griots. I can send you an article or a paper if you want to read. So people have written about griots and what they did, but I think griots did not themselves write. So that's what I wanted to say.
But I
Yes.
have a basic question.
Yes.
The oral tradition is something that we all cherish.
Yes.
But the thing is, there is also a danger that the oral traditions or the oral, history can be sometimes exaggerated, or
Yes.
things that are not actually the part of knowledge can be incorporated.
Yes.
Yeah.
which is why there has to be inputs from people doing science, because there has to be a balance between. So the oral telling, storytelling format and approach is excellent and it should be used, but there has to be a check on the scientific knowledge, because we live in a day and age where it's very easy to share misinformation through these things, and things get exaggerated. I agree with you. But there is a fine line between exaggeration as a creative liberty versus exaggeration with the intent of actually sharing wrong information. So those are very subjective things. They can only be decided on a case-by-case basis. But the point I was trying to make is not that every oral storytelling tradition should be communicating science, but scientists should be partnering with people doing storytelling traditions to work with them together, because they can provide the accuracy and the oral storytelling people can provide the entertainment and the accessibility, right? So there has to be a yin yang or a balance of accuracy and rigor of science with the entertainment and the accessibility of that. So that's what I meant. Sorry, I should have clarified that better. So the grades example has been going on since the 16th century, but in 2013 and 16, when the Ebola crisis hit, there was a widespread misunderstanding or public mistrust of Western scientists and medical professionals. So a lot of people from the UK and US came to Africa to help the people and give them medicines, but all the black people there were very, very skeptical and doubtful of all these Western savior, people. And that's because historically they have been cheated, they have been they have faced a lot of bad things when white scientists or white doctors want to come, because they have been used as test subjects for a lot of medical therapies. So they have a historical distrust of medical practitioners and doctors, and they were not wrong from their point of view to be doubtful of them, right? But so the doctors were actually trying to do good. In this case, the doctors from US were actually trying to do good, but they were not able to reach the people, and people were not listening to them. So what did they do? So this mistrust was rooted in a mismatch between the scientist approach and the audience's cultural context, which is the history of being received by these doctors. So eventually, what they did is they got the creators to come and tell these local communities to talk about what is Ebola, how does it spread, what can you do to avoid getting the Ebola infection, and what kind of medicines you should be taking. So they recruited the local community people, which are the creators, because they were belonging to the community. The people were much more receptive to them. They were much more open. They trusted them much more than the white scientists who had come from the US. And so grades became sort of a medium or a mid ground or a bridge between the Western scientists and the local communities. And the grades campaign of preventing Ebola and curing Ebola actually was very successful. And this has been something that's been written about in Africa. And this happened only in the last 1 decade. It's not even very old. It happened in 2013 to 16. Right? So the Koreans basically use regional languages, they use a lot of local examples, they use a lot of local folk traditions and stories and everything, music stories, everything, and they actually succeeded in communicating that this is how you should be avoiding Ebola, and this is how you should be curing Ebola. So this seems like a great way to creatively combine Western scientific knowledge, exactly what I said, with traditional knowledge, local languages, and cultural practices for more accessible knowledge sharing practices, right? So the idea is not one extreme or the other. The idea is to harmoniously combine these two things and find a way. And I think that is the crux of what knowledge sharing or science communication is, right? How do you find an interesting and entertaining way to share technical and difficult to understand science in a way that people find it interesting to listen to, right? That's the holy grail of doing science. So indigenous traditions and practices don't have to be in opposition to Western ideas like scientific thinking. A lot of times we think that anything that is Indian or developed in India is the opposite of Western scientific thinking. They don't always have to be opposite, right? Sometimes there is a lot of scientific thought and thinking. For example, Ayurveda. There's a lot of stuff in Ayurveda that actually works very well, but it has not been scientifically studied to that extent, right? What we need is we need more scientific studies to properly assess what is the impact and stuff, rather than saying that Ayurveda does not work at all, right? So Western science and Indian practices, culture, traditions do not have to be polar opposites. They can be combined in a harmonious way, and that's what we need to be figuring out how to do. So that's basically a partnership between a scientist and an artist, and how we can sort of develop the yin and yang or the balance between these two things. Okay, so the last example, the last 5 minutes I'll finish. So the last example is about something much closer home. This is something that happened in India in the 1960s to 1980s. It was called the People's Science Movement. Does anybody know about this? I'm sure a lot of people have been alive here, actually must have been around, like I was not there probably, but so the People's Science Movement was basically a social reform movement which happened where a lot of scientists, social reformers, activists, theatre actors all of them went from village to village, and it was a very diffuse movement. It happened in many parts in many periods of time, but it catalyzed or it became sort of condensed when there was certain sort of, so for example, the Bhopal gas strategy was one catalyzing event, after which there was a lot of activity that happened. So let's take that example. So at this point of time, a lot of scientists got together with social reformers, actors and musicians and everything, and they toured different villages and they actually reached out to millions of people in a span of a few months, where they had coordinated these traveling across the villages. And the interesting thing is that they actually critiqued scientific information also. It was not just about sharing scientific information as the savior or the problem solving or this will solve all your societal problems. It was not that. It was actually questioning science, whether you should be having a nuclear power plant, you should be having something like, can we afford to have another Bhopal gas strategy or not, right? So it was about being critical of scientists, about questioning science, about asking difficult questions to scientists and scientific institutions. And I think that is the next level of science communication where we need to go towards, right? We need to be not just taking in science thinking that science is always correct or scientists are always right. We should be challenging scientists with our own questions. We should also be saying that, do you think this is the right thing? Do you think we should be developing this stem cell therapy? Is it the right time to do this? Can we afford to do this at this extent, right? So questioning science, critiquing science is the fundamental crux of science itself, right? Science believes in questioning everything, not believing anything at face value. It involves questioning everything and asking a question mark at everything, right? If you cannot question science itself, then it's very ironical, right? So the point is that people should be questioning science, not because they want to sort of, prove scientists wrong, but because they want scientists to be able to give answers to them which are satisfactory to them, right? So the People Science Movement was a great success in terms of critiquing and questioning science, and it actually led to a lot of adjustments of how fast scientific development in organization was happening in post-independence India. So these groups of people science movement basically traveled across villages in the country. They organized science themed public lectures, discussions, performances, films, interactive demos, all sorts of things, right? And this was very successful. So the learning point from this is that more scientists should be working with artists and social activists to engage different kinds of public, as long as scientists treat them as equal collaborators and not as a sort of just a equipment or a medium to get to people, right? So there has to be equality and collaborative spirit between the different actors who are doing this kind of stuff. You cannot say that, I'm a scientist, I will hire you, you do this, and then I will let you go. That doesn't really work because then they don't have agency to change and adapt things the way they want. So the artists and the social reformers and the theatre artists and so on and so forth should also be able to bring in their own experiences and adapt and shape things in the way they want. So People's Science Movement often emerged as forms of social activism aimed at addressing the challenges of urbanization. So it was not just about sharing scientific knowledge and making society better, it was also about making science go at a pace which was comfortable for society to adapt to, right? So urbanization in certain parts of India was happening at a very fast pace, and it was not healthy. It was harming the environment, it was harming communities, it was displacing a lot of people who lived in villages. And I think scientists were only thinking from the scientific point of view, but there are other things to also think about: economics, politics, social culture, all kinds of things, which are also equally important forms of knowledge. And I think this kind of social activism basically kept the scientific force in check and made it see that there are other forms of constraints and push and pull measures that also need to be considered when you're thinking of society as a whole, right? So it is in some ways making scientists more humble kind of a sort of a approach, which I think is very important. They shared important scientific messages, but also listened to citizens' experiences and concerns about health, sanitation, energy, and agriculture. So the dialogue that I mentioned about initially was a very important consideration because when these people science movement activists were going from village to village, they were also listening to what concerns the local communities had. They were listening whether they were, there was too much urbanization happening, whether they had access to clean water, whether they had sanitation measures, and so on and so forth. So there was an equal element of listening and taking in their experiences as much as there was pushing your information. So there was a push and pull of both information happening in both directions, which I think is also important. So that's a great example of public engagement and science communication that helps scientists and public groups to learn from each other. It also led to community building and sped up social reform. So this also had a side effect, which was greater community building. A lot of people started, identifying and talking to each other, and so it also helped the community building in the long run. So I'm now coming towards the end of my talk. So in conclusion, I want to say that there are so many more examples of knowledge sharing practices across the world. I have just given you 4 examples from the UK, Australia, Africa, and India, just to give you a snapshot of what science communication and knowledge sharing looks like across the world. And they're also different points of time. So the UK was 1990s, India was 1960s, Africa was 2013, and the original was 10,000 years ago. So I've also tried to cover different periods of time. There are different continents, there are different cultures. So this was a snapshot of knowledge sharing practices across the world. There are many, many thousands of more that you can read up more about, and which I would encourage you to. There is an incredible diversity of traditions and approaches for knowledge sharing across the world. We should be discussing and learning more about this history of science and science communication rather than just white scientists in English-speaking countries. We should also be talking about scientists who have not been, as famous or have not got as much attention as some of the famous scientists. One last parting note before I finish is that institutions should not hijack and adopt these traditional and cultural practice as their own innovative forms of cyclone without permission. You should involve the local communities, the local folk artists, the creators, the theatre artists, and make them also give them agency to also do this, rather than just saying that this is interesting, I will take this and I will make it my own. Right? So it's important to give them agency, to make them partners, to make them collaborators, and I think that spirit of collaboration is very, very important for doing science well and doing science effectively and ethically. It would be much better if we included all cultures and allowed everyone to claim the term science communication or knowledge sharing practices for themselves. And I think that's the way we can sort of build a community, an ethical, effective, and a trustworthy and an effective community of people sharing knowledge with each other. In this way, we can also work towards a deeper acknowledgement, inclusion, and acceptance of diverse voices, diverse people, diverse viewpoints, diverse forms of knowledge that I mentioned in the beginning, as well as knowledge sharing practices. And history teaches us that there is a wide variety of approaches to knowledge sharing, which is informed by various science communication efforts across the world, across time, continents, and cultures. But the most impactful forms of knowledge sharing practices ultimately involve people who listen to their audiences, build meaningful relationships, maintain trust, and work with others to make scientific knowledge more inclusive, accessible, and relevant. And I think that is the crux of why I'm sharing this with you today. With that, I will conclude. Thank you so much. We have time for questions now, right? Yes.
How about superstitions becoming scientific
Yes.
knowledge somewhere or the other?
Yes. So I think I'm very glad that you raised that. So I will also add one more point. So in India, the science communication and knowledge sharing that happens is very, very different from what happens in the West. For example, I studied in the UK and I was working as a science communicator there. But when I came back to India and when I tried using all those new concepts and things I had learned there, it did not work at all. And I realized that in India, doing science communication was very different for the following reasons. The first thing is scale. Everything that happens in the West is 10,000 people in a city and that's it. That's a very, very small scale. In India, the average population of a city is 100 times more than that, right? So anything that happens in the West has to be scaled 100 to 1,000 times in India for it to even reach 5% of the population. So scale. Second thing is language, which I think Kolagara should be talking about it. He's the expert. In India, every 100 kilometers, the language changes, right? And you cannot just communicate science in English and get away with it. You have to be doing science communication and knowledge sharing in different languages. And I'm so happy that all of you guys are doing such great work and you're getting science in Kannada to different kinds of communities. And I'm sorry I'm speaking in English, I know, but I'm so glad that you guys are doing such amazing work. So scale, language, urban-rural divide. What happens in a city like Bangalore is very different from what happens in a town like Hubli, right, for example. So there is also an urban-rural divide. The fourth thing is superstitions and pseudoscience. In India, there is so much of superstition and pseudoscience that we often don't know how to deal with it, and we cannot objectively go and correct every superstition or pseudoscience. It's not possible. The solution to that is to teach people how to fish. Is to teach people that you should be thinking in a scientific way, you should be developing scientific temper, you should be developing inquisitiveness and curiosity, the spirit of scientific inquiry, as the gentleman pointed out in the beginning. And it is to make people, to enable people to start thinking in a way where they can differentiate both between what is pseudoscience or superstition versus what. So if you can question, the cat just passed in front of me, should I be crossing? You will believe it without thinking. But once you start questioning everything, what happens? Let me try crossing the path and see what happens. Nothing happened. Let me try it again. You do it 5 times and you realize, oh, nothing actually happens. So it's a superstition, right? The thing is, the idea is that you have to start questioning everything around you. That's the only way we can overcome this because we cannot keep up with the pace or the speed at which misinformation and superstition comes at us. Like During COVID, there was so much pseudoscience and superstition and WhatsApp forward that was coming to me, and my entire family was sending me stuff. Can you check this and tell us whether this is right or not? And I am like, I can't do this. It's crazy. It's not possible because it's just crazy. And then I took my time. I clarified some stuff. But over 5 or 6 months, I told my family WhatsApp group that anything that comes to you, question it. Look who sent it. Does it have a source written to it? Is it someone that you recognize? Is there a way to go back and check the credibility of this? Is there something which are making an absolute claim? If someone says that this herb or Ayurveda thing will cure COVID, is there a way where they have shown that there was a possibility it might not work? Are they being skeptical themselves, right? So there are many small things that you cannot teach people, but you gather by experience. When you start questioning things, you also start realizing that maybe I should ask this question before I believe in this. Maybe I should check the WhatsApp forward before I send it to someone else. So when you start questioning, that's the only way you can tackle this. Because in India, with the scale of superstition, I don't think 10,000 people like me also cannot handle it. So it has to be enabling people to start questioning, to become skeptical, to become critical of things, right? And question things. Don't believe things when you hear them. Ask questions, ask people, and if you don't get the answers, trouble them, push them, write emails, go to Collegala, write to me in NCPS, and just bother people, and that's the only way you will get your answers. So you have to have a little bit of being unabashed and shameless in asking questions also. You should feel entitled to ask questions, right? I mean, you're in this world, and the world is your sort of motto. You should ask questions. I don't know if I answered your question, but yes.
There's another, is it possible that some of the superstitions among the millions could be actually scientific facts?
Yeah,
Yes,
I
absolutely.
was to come to that.
Yes.
So it's not, I'm putting the question in a different way. See, there is a theory, or there's a, so when you talk about practical knowledge and the knowledge sharing practices, it is said that some of these ritualistic practices that we have are actually knowledge sharing. But then, where do we distinguish between an actual ritual and the knowledge?
See, when a ritual becomes a norm that you have to do it every single time, it is in gray area. If the ritual is something that you can decide to do or not based on whether it works for you or not.
I'll give a specific example,
Yes.
and please excuse me because I'm a Brahmin, so I know this. Okay. So when we do the Upanayana, so there is a practice where they teach, rather they say as a ritualistic practice that you have to plow the land. Okay, that plowing is actually shown. Like sort of a theoretical way, so you have to get a gold ring only and do all these things. I think many of the people may be knowing this. So that is a ritual practice, whereas probably it was a teaching method some time back. But now, is there a relevance to have that here as a ritual?
Yeah, I
That's the
I
question.
can also differentiate between superstition and ritual. So, like the cat passing in front of you is a superstition, and what you are saying is, plowing the land, or for example, when you do a yagya, when you move into a new home, the yagya is actually very scientific because of the flame and everything. You're killing a lot of the microbes and spores and everything. So, even though it seems like a ritual and superstition, there is scientific basis to it. Or, for example, drinking turmeric milk when you have a cold, or things like this. These are there have been no scientific papers to show it, but I think it makes a lot of sense because here's how I will decide. So if I have a cold and I drink turmeric milk and my cold actually improves, I'm actually doing a scientific experiment where I've tried this 10 times in my life and it works. So I think it's scientific. That's the definition of scientific. The definition of scientific is not that there has to be a scientific paper published and said by WHO or whatever. If you in your life, in your own experience, can test it and if you are open to the fact that this may or may not work, and if it works for you, I think it's as simple as that. So if a ritual works for you and if it brings you whatever you're looking for, I think as long as it's not harming other people, it's very difficult to scientifically test every ritual we have, right? You cannot, but you can use your own sort of questioning and judgment. I mean, that's what I do. I'm sharing my own experience.
I'm just sharing.
Yes.
I suppose the being the international science festivals across the world,
Yes.
whether it's Europe or America or Australia, they're employing a lot of theatre and musical things.
Absolutely.
It's already there for quite some time. And then sharing has been there traditionally, and otherwise I don't think we'd have come to the I mean, artificial intelligence level unless sharing is being there.
Right.
Exclusivity or otherwise is very difficult. Even Einstein is supposed to have claimed that I would never have said E is equal to mc square because of the atom bomb from alien from planet.
Yeah.
There are many ways of thinking.
No, I think a lot of scientists have also said this. So, for example, Feynman has said many things about sharing science, and even Einstein has also said things about sharing science. So, I mean,
Yeah.
that's there. But in general, if you look at the scientific institutes in India, at least until 5 years ago, all of them were very sort of closed. It was not easy for you to go inside and talk to scientists. Maybe in Mysore is different, I don't know. Maybe CFTI is more accessible. But in general, all the cities that I have been in, it's usually inaccessible. And I think the rationale for the reason why I'm talking about this is that it has been there. I'm not the first one talking about this. This has happened for tens and thousands of years. But I think scientists today are only trained in the natural sciences, and they sometimes forget that there are other humanistic and social aspects of life that they also need to think about. They live their lives in a very full way, but when it comes to connecting back to society, they can sometimes be very sort of eyed in a very certain direction. So I think there is scope for broadening the horizon, and saying that reading literature can also make my sort of my scientific understanding. All the best scientists I know. Let me give you an example. So Raghavendra Gadadkar is a scientist at IISc where I studied. He was also my teacher. He's someone who reads two books, non-scientific books every week, I think. And he cannot read, so he listens to audiobooks or podcasts. And he has such an insane amount of knowledge about all kinds of literature and art and theory outside of science. And I think that absolutely makes his science 1,000 times better. It has nothing to do with science, but him reading literature and art and mythology and folklore and whatnot actually contributes to his way of scientific thinking, and it makes his thinking so much more wider and more porous to different kinds of things. And I think just for that itself, there is merit in trying to broaden your horizon and opening up how you think about it. So, and this is true not just for scientists, for anyone. If you are a accountant, if you are a social scientist, if you are a doctor, you should read up and listen to things outside your field of knowledge or your field of expertise or your job or whatever. Right? It's always good to open your horizons and I think let things come in, right? Because your cup is full, but then when things start coming in, your cup will also get empty and you will make space. So, yes.
Slightly away question.
Yes.
What is the India's policy on stem cell research? And specifically, what kind of work goes on in NCBs?
I don't think India has a very sort of straightforward policy in stem cell research. I'm not an expert in stem cells, but I don't think there's any national policy as such, but there are a lot of regulatory authorities. For example, every time you do any research in an institution like NCBS, there has to be a very rigorous ethical approval process where you have to say you're doing this and this. And in general, anything involving human samples, human tissues, or human embryos is very, very highly regulated. So it's not easy to do these research, which is why most scientists will work on other modern organisms like flies or mouse or something, which is easier to get permissions for. That being said, there has to be some research that happens on stem cells because ultimately you have to test the things on human tissues and human embryos for it to actually work in humans. But those are sort of more downstream processes. So NCBS only does basic science. So we don't actually work with doctors to create a therapy. We basically just study the things at a very fundamental level, and the further application of that science happens by other startups or biotech entrepreneurs or something like that. That being said, one thing that I wanted to mention is that, sorry, I forgot completely. Yeah, so stem cell. So there is one more institute in our campus which specifically studies stem cell research. But even there is no therapy being developed as such. It's mostly studying how the cell works and how things happen in the human body to provide a more foundational understanding of how we can develop therapies. The actual development of the therapy is something that we don't do. I don't know if that answers your question. I mean, it's difficult. Yeah.
Yes. There is another superstition is one, and the second one is about the misinformation or advertisement, which is
Yes.
more, where they spread purposely scientists or people really going out saying that.
Yes.
this, so how does that, yeah, or for economical benefits? Where do that?
Yeah, so I mean, it's very easy to demonize scientists and say that scientists are, they don't know what they're doing or they are taking all this money and doing this. And all that happens, maybe it's true to some extent. I will not contest that. But So misinformation, the problem is that they are far more advanced and faster and equipped than scientists or science communicators who can refute them, right? Because misinformation, the thing is, the burden of proof lies with the scientists because they have to prove whether they're saying is true or not. The burden of proving something right or wrong does not lie with the people who are spreading misinformation because they can just make up something and spread it, right? So they're much faster, it's much easier for them to say things, but the scientists take a lot more time to find out or to provide conclusive evidence that this is true or not true. So in general, by principle, by definition, scientists and science communicators are always going to lag behind people who are doing pseudoscience and spreading misinformation and disinformation. As I said to this gentleman's question, the only way you can get around is that you make people ask more questions. You make people skeptical, you make people doubtful of things, and let them ask questions and only be convinced when they have enough sort of answers.
Yeah, where I was coming from was that, see, I think there must be a way or a channel where they refute all these things. Because most of this happens in via TV or via a radio,
Right,
which is
right.
a mass, and if a title or a person wearing a white coat or wearing.
So, yes, yeah, I got your
believe
question.
that it's a scientific.
So there are fact-checking websites on the internet which refute this. During COVID, there was a website called COVID Yarn and Inside COVID, where they came up with mythbusters of all kinds of misinformation going on, and they provided scientific evidence. And it was a voluntary group of, I think, 200 or 300 scientists who came together. You were also part of it.
We are also part of that, and in fact, Prakash was also part of that.
Right. So there are initiatives like this, but I don't think it's going to be ever enough to refute everything because anybody can make a WhatsApp forward, right, and share it, right? How are we going to catch up forward that? It's impossible to, be. And the other thing is that scientists also take a lot more time to say something conclusively. Scientists will always say things in tentative terms because they're never sure of something, right? They will say that as far as we know, based on our current understanding, this is there, and in 10 years it might change completely. And scientists are very aware of that. But that makes them look like they're not sure of what they're saying to the people hearing them, right? And that is a fundamental problem because we only communicate science as the concept or the fact of science. We don't talk about the process of science or how science is done. If we share how the process of science happens and that there is uncertainty built within the process of science, I think a lot more people will be much more equipped to sort of understand that scientific knowledge is always evolving and expanding, right? And scientists are not lying or they are not saying the wrong thing. Based on their current understanding, they will give you the best answer. But there will always be a 5% chance that it might change, right? And that is the nature of science. If science did not change with evolving knowledge, then science would not be as powerful as it is today, right? The fact that science can adapt and change based on new information is the fundamental foundation of science, right? And it is not a flaw or a negative aspect. It's one of the biggest strengths of science, right? So science has to be uncertain. It has to incorporate uncertainty. It has to sort of have space for things to change because then we'll be doing a disservice if we made one decision and then we stuck to it, right? Because even historically in the history of science, you can look at many examples where we thought that the sun went around the earth at some point, right? If we had believed that as scientific truth and gone with it for the last 300 years, we would be wrong, right? But when new evidence came, we realized that the earth goes around the sun and not the other way around. We changed it, right? Similarly for evolution, we used to think that so and so happened, but then the principle of evolution, natural selection, Darwin found out how natural selection works. We changed and updated our sort of understanding. Same thing with, for example, how diseases were caused, right? People thought that it was bad influence or bad humors that causes disease. That if you had black bile or yellow bile, these were the causative agents of disease. When microbes and microorganisms were discovered, we realized that these microbes were actually the causative agent of disease, and you can just take an antibiotic or an antiviral, whatever, and it can actually cause. So science has to be tentative, there has to be uncertainty, and it has to keep evolving. To answer your question, with misinformation, I think we just have to question things. And you have to also, if you're not sure, you can ask scientists, but then you cannot expect scientists to be running behind every sort of misinformation person and trying to say that this is wrong or that is right. I mean, some scientists do that to some extent for big things like COVID vaccine and stuff. A lot of scientists did something. It was urgent. It was very important. It was topical. But I think in the day-to-day basis, it's very difficult to do that. It's very challenging. So it's difficult.
Just a comment.
Yeah.
We think that there is any information that is coming to us is a misinformation. Even if we have it out, then we should stop there without forwarding. That solves a lot of problems.
Yes, I agree.
There's one more challenge when we use the Indian languages because the words already come with culturally loaded meanings. So
Yes.
it's very difficult to represent the exact knowledge of science in the Indian language.
Yes, I think he should answer for me. He's the expert.
Now, there are two things about this. So when we communicate science, there are two aspects of it. One is instruction, where we want people to learn specific concepts, only the, what we call as deeper knowledge. In that case, we look for specific words and all these things. But in general, if we have to talk about a concept, probably we all have heard and sensed those things. So those words which express our, feelings are enough for that. So for example, when we say a ball goes up and comes down, that is also a part of gravity, but that's what we should be telling. But when we are talking about specific gravity, that is m into a, mass into acceleration and all, then probably we need a word. And we face this problem when we teach, especially children with regard to ಭಾರತದ ತೂಕ ಮತ್ತು ದ್ರವ್ಯರಾಶಿ. So we know that mass and weight. So these are concepts which are different for scientists, but for us it's the same.
I will answer that question just to add to his point. I'll just say this in the other way around. If you're using English words or words that people are not familiar with, they take double the amount of cognitive effort to understand, because in their head they're trying to understand what the word means and they're trying to understand the concept which you are explaining using those words. If you use words which have a cultural context and they recognize it, they will absorb it much faster. It reduces the cognitive amount of work required for them to understand. So I will read it the other way, that if you're using cultural examples that have a meaning, you can use those as metaphors to make people understand things much faster. For example, if I'm showing an example, I say Tom, Harry, Megan, whatever, I use English names. As opposed to that, if I say Ram, Sita, Gita, it's much easier because people don't have to think about who these people are, right? So just a simple thing of using Indian names changes things, right? Scientific terms, again, as Kulagala mentioned, sometimes you can use the English word, but explain them and use it. But sometimes you also want to use metaphors. So if I say a metaphor, say for the blueprint of life, right? For DNA, I'm saying the blueprint of life. Now, nobody knows what a blueprint is, nobody knows what a DNA is, and I'm confused what is blueprint, what is DNA, what is life. But when you say something which is based on the local context, right? Something which is much more recognizable to us from our Indian context, it's much easier to understand. So I will actually see it as a benefit, even though there might be caveats or places that they might misunderstand. You can explain it to them and then say that, hey, but you need to be careful about not understanding this. That is much easier because then they understand it and then you correct them and you put them in the right direction, rather than using a word which is completely alien to them and then they're all confused. So it just goes over the head. Yes.
Encouraging science fora in the schools and colleges and establishing museums, science museums in all towns to start with. Will it not help in a big way for science communication?
Has not helped, you're saying?
Will it not help? I'm just.
Oh, will it not help? I mean, of course it will help, but I think the way museums are designed in India are very sort of static. They're like, there's one object, one more object, you see this and you understand. People get bored. If I was a kid, I wouldn't want to go and spend more than a day in a museum. Once maybe for the sake of novelty. Whereas if you go to museums which are more interactive, more dynamic, where things are happening, where there are people behind counters, they're doing experiments, where you get to do science. So learning by seeing versus learning by doing, there's a huge difference. So the museums that we design need to focus on learning by doing rather than just learning by seeing. Because by seeing, you're only getting 10%, 20% of the science. By doing, you're actually applying that scientific knowledge and internalizing it to a much greater extent. And I think that is what needs to happen. So museums have a great role to play, but I think it has to be upgraded a lot more than what our Indian museums are doing. Like there are science museums in Bangalore, in Calcutta. I've been to many of them, but I don't find them interesting. So I feel like there has to be a lot more that needs to be done. Yes.
Yeah, so you said that the burden of truth is on the scientist, or the burden of truth is on science. If we juxtapose that on, science itself being embedded in uncertainty, like you said, the process of science is uncertain and it will evolve to perhaps a greater truth at a later point in time and stuff like that. I also feel that the burden of truth or the onus of responsibility is as much on the science communicator because it is imperative, especially in a country like India, not to be trigger happy and to be communicating ahead of time because the cost of correcting that later. When I say cost, not the financial cost, but the social cost of correcting that later, if we go ahead and communicate something and then if we have to layer that upon something else, that might be so much greater and therefore discretion is the better part of valor when it comes to communicating scientific stuff. I mean, it's
Yeah,
more
I get
long
what you mean.
thinking than asking a question.
Yeah,
What
yeah.
do you think?
No, so when I said scientists, I was meaning scientists and science communicators trying to, bust myths on one side and the people propagating misinformation on the other side. So you saying that science communicators also have responsibility, I agree with that 100%. Me too. Rather, the second point about having discretion on what to share, I agree with it in principle, but in practice, it's important to also keep communicating updates because if you do not communicate for a long period of time, you're also creating a vacuum where all kinds of other negative actors will come and push information. For example, during COVID, because scientists were hesitant to share updates about COVID science, because the COVID science was not fully mature and developed, they held back because they wanted to put out a final word or a more concrete answer. They held back for a very, very long time. In that meanwhile, a lot of negative misinformation people came and filled it. And I think that is also problematic. The second thing I will say is that when you are doing something like busting COVID or COVID related myths, there has to be a longer term engagement with the public. It cannot be that you just come in and say this has to be done, that has to be done. The public has to trust you. There has to be a long term trust building exercise, and that takes years. It's not a 1 day or 2 day or a 1 hour talk like this will not change anything, right? You need to be engaging with your local communities over years. When you have that trust with them, then you can really talk to them and say that this is what you should be doing.
Scenario what you're saying is right.
Yeah.
But in a scenario where the caveats that you will offer to whatever is the outcome that you're presenting is going to be forgotten, in a
Yeah.
scenario like that, it's highly likely that there will be greater disbelief than belief if you communicate ahead of time. I think what stage to
Yeah, I get what you
communicate is what is very critical.
That's
the point that
it's a
I'm
very
saying.
subjective thing. It will depend on case to case, but I hear what you're saying. I agree. Okay, fine.
We have time for one more question.
Last question.
Last question.
Preferably by a woman.
No,
because-
it's not the question. One more question.
Oh, okay.
Questions will be played.
Okay, sorry.
Okay.
Any woman wants to ask? I feel like all the questions were mostly asked by men, and I feel uncomfortable about that. Anybody would like to ask anything? Yes.
So, how do you actually share about the process of science, right? Because you have, from the beginning of the talk, we've been saying that we should foster collaboration. But how do you sustain such collaboration for a longer time? I mean, COVID-19 was a catalyst for the past 2 years, and we had a lot of these collaborations.
Yes.
But I slowly see them sort of weighing down.
Yes.
So how do you keep it going?
I mean, the fundamental, more foundational problem is the attitude that scientists have towards society. They often are very condescending and they think that we know more and so we don't need to care about. But I think one reason that I will give is that all the science in India, most of the science in India is funded by taxpayers' money. So it's your and my money which is funding the science in India, and scientists have a responsibility to engage with people. To what extent, at what time is their discretion, of course, they're busy. But I think it is a responsibility, and they are not doing a service to people to educate them. That's not what they're doing. That is a very sort of one-directional thing. They're also doing it because they want to understand what's going on in society. So they should also have an understanding that they will learn out of this as much as they will teach people. So that's one thing. How to do it? I think in terms of talking about process of science, I think one very simple way of talking about process of science is to share your science not just in terms of the facts and concepts and the technical words, but to talk about your journey in science. How did you become a scientist? Why did you become a scientist? What did you do in the lab when you saw failure and you troubleshooted and you did this for a year and did not work? When you talk about failure, when you talk about troubleshooting, when you talk about your own ups and downs in science, it makes you relatable to people because everybody goes through failures and success in life, right? And even if people don't understand your science, the technical stuff, they will relate with you because they have also gone through ups and downs and failures and success. So that is a very easy way to connect with your audience. And that also talks about the process of science because you're not showing science as one final banner of success that you have achieved. Behind that banner of success, there are 1,000 failures also. So when you start talking about the failures, it also makes people appreciate the process of science. It makes them understand uncertainty. It makes them relate to you better. It makes you more relatable and human. And scientists are not someone at the pedestal, they also become more human. And people start relating with you and they will also be more comfortable asking you questions when the time arises, like COVID or something. So for example, I said that my family, my entire extended family reached out to me, even though I'm not a scientist anymore. They reached out to me because they saw me as someone who could provide credible information. And they reached out to me because they had that trust with me, because they knew that I want their best and they're my family. Of course, in this case, it's my family, so it's easier. But I'm just giving an example that they knew that they could reach out to me and I did as much as I could to bust the myths and share. And after 6 months, they actually started, sharing things. And then before I could respond in an hour, they're like, oh, actually, I don't think this is true because I didn't find this. So they themselves started looking at all the things that I would look for. And I did not teach them this. I did not tell them that I looked at this. I just told them that I don't think this is a very, a proper source because I didn't see that. So I made one-off comments and dismissed half of the stuff or half of the forwards they shared with me. But then they started discussing and telling themselves, and my family group started talking about these things without me being involved. And that is the place where we all want to be, right? When you are not the necessary element, you are just a catalyst to make people ask questions. And then it becomes automatic. Once they get the hang of asking questions, it becomes organic, it becomes embedded. And I think our education system also has a big role to play in this because the way we teach science is very fact heavy, it's not process heavy. And I think that is the bigger challenge that I don't know if I can solve, but there is something to be said about our education system also. And I'm glad that people like Shashi and Kolagala are doing so much stuff because it really sows the seed of inquiry and curiosity and skepticism and questioning that often in school students are told to shut up and listen carefully, right? They're not encouraged to ask questions, not outside of certain few minutes in pre-class, right? And I think that also is needs to change. So I'll stop.
Thank you, Siddhartha. I don't need a minute. Siddhartha and I came together probably 3 years or 4 years ago, but he has been a guru to me in several aspects.
The other way around, I should say.
And especially in terms of science communication and researching on science communication, a good amount of work he has done. And another area which we in Kannada we feel a vacuum is that the science cartoons. You will see the cartoons that he has brought it up with his colleague, and these are wonderful. And Siddhartha is very passionate, much more passionate, and I think that he is someone who will lead the science communication in the coming years. And it was very nice of you, Siddhartha, to come here and speak to us about and I now, on behalf of Kamasurji and Kutubali, I request India to present it. And
Yes, sir.
History of Science is a program that we have planned, and this is the first one of the series. And this will be once in every 3 months, the third Sunday morning, 10:30. We will be having this program regularly, and we will try to get people like Siddharth to come here and discuss about the history of science in various disciplines. We wish more of us will come together and discuss so that the science becomes a inclusive, totally inclusive aspect, at least in Mysore. Thank you very much.